Hello everyone. Today we will see an important and powerful concept of geometry, that is shift of origin. We need formulae for shifting of this origin. Let us see how those formulae can be derived. For that, we will take our usual XY system. This is x-axis and line perpendicular to x-axis is our capital Y-axis. Obviously, this point of intersection of both axes is our origin. Let us write those points. That this xy is our original system or old system. Original or old system. O is origin. Its coordinates are obviously 0, 0. Let us take O dash be any point in this system here. O dash is a point in this system whose coordinates are nothing but HK. HK are the coordinates of point O dash, and P be any point in the same system with coordinates small xy. Because if you take system capital XY, then conventionally we take coordinates of any point as small x and small y. So, do you know the meaning of these points? If point O dash has x coordinate h and y coordinates k, this x coordinate is nothing but the distance of point from y axis. So, if you draw perpendicular from O on y axis, then this foot of the perpendicular drawn on O on y, its distance, the distance of this foot from the origin is nothing but x coordinate, and its perpendicular distance is nothing but its y coordinate. So this is h, that is the distance of point from y axis is nothing but h, and if you draw perpendicular from the same point on x axis, then this length of the perpendicular is nothing but its y coordinate, that is k. So this distance is h, this distance is k. Obviously, these two are perpendiculars. This is already perpendicular, so this quadrilateral is a rectangle. So opposite sides are equal. So this is distance h, and this distance is nothing but distance k. This is our point O dash, whose coordinates are hk. If you think about this point P, then this x coordinate is nothing but the distance of point P from y axis, and y coordinate is nothing but the distance of P from x axis. So if you draw perpendicular here, then the length of the perpendicular, this is nothing but distance y or number y, that is the y coordinate of point P. If you draw perpendicular from point P on this axis, then the length of the perpendicular is nothing but x. Again, these two are perpendicular, this is also perpendicular. So this quadrilateral is a rectangle. Let us give the names here. This is suppose point N, this has N dash, this is O, this has N, and this has N dash. Then let us now consider that we are shifting origin from O to O dash. Actually, O is the origin of our XY system. So in this XY system, we have taken points O dash, that is HK, let us consider this as O dash as fixed point in old system. Then its coordinates are, we have taken hk. Then what is P? Pxy is nothing but point in old system or old XY system. Okay, this much we have taken till now. Now the next different thing that we are going to do here, that we are shifting this origin O to O dash. How it is possible? If we shift this x-axis here and if we shift y axis so that it passes through point O dash, then obviously this origin will change to O dash. So for that we will consider here this line ON dash as our new x-axis. We will call it as x dash, and this line OY is shifted up to this O dash, so we get this line which is our new Y dash axis whose origin is O dash. So this x dash O dash Y dash is our new system. So we will write here x dash Y dash is new system. This xy is original or old system, and this x dash Y dash is new system whose origin is, this is the O dash is origin of x dash Y dash system. Obviously in this system the coordinates of O dash will be 0, 0. Actually those are HK in old system, but in new system the coordinates of O dash will be HK. So what we have done here, we have shifted our origin O to O dash. This is the main change we are doing here. We are shifting origin from O to O dash. Let us see once again. Obviously we have changed this system, so in this system the coordinates of P will be different because its distance from origin is different. So we can say that capital X and capital Y be the new coordinates of point P in system x dash y dash. So this capital X is nothing but its distance from y axis. So this will be now capital X. And what will be y? Y is nothing but its distance from x axis. So this will be capital Y. Again, these are distances. Obviously, they are perpendicular distances. If this x dash axis and y dash axis both are also perpendicular to each other. So again, we get here rectangles. This angle will be obviously right angle. So here all quadrilaterals, whatever we are seeing here, all those are rectangles. Now, if we observe this carefully, then this distance x is nothing but this. This is also OM. So this is distance x. This is y. This is also y. This much is y. So this OM is nothing but again y. Now, if you observe this figure carefully, then in this figure, if we find distance OM, this distance OM, then this OM is nothing but OM. Here M dash is between O and M. It means O, M dash and M are collinear. O, M dash and M are collinear. These 3 points are O, M dash and M. These 3 points are collinear. So distance OM is nothing but OM dash by collinearity of points, OM dash plus M dash N. But OM is nothing but X. OM dash is nothing but H. And M dash, that is nothing but this. That is the same as capital X. So we get small x equal to small h plus capital X. Similarly, if you see towards y-axis, then on y-axis this ON means point O, N dash and N are collinear. Points O, n dash and n are collinear. Therefore, we can write On is nothing but On dash plus n dash n. On is equal to On dash plus n dash n. On is equal to On dash plus n dash n. Let us put those values. On is nothing but this On is nothing but y, small y, and is equal to On dash is k, that is this much k, plus n dash n, that is this distance, means this, that is the capital Y. So we get y is equal to k plus capital Y. So we get these two relations. This is the relation between x coordinate of old x coordinate of point P. H is the origin, x coordinate of origin, new origin, and capital X is nothing but the new x coordinate of point P. This y is nothing but old y coordinate of point P. K is y coordinate of new origin, and capital Y is nothing but the new y coordinate of P. So these are two relations in x, h capital X, and y, k capital Y. So these relations are nothing but, or these equations are nothing but the formulae for shift of origin. So we will write here formulae for shift of origin. Those formulas are small x equal to h plus capital X and small y is equal to k plus capital Y. We can write the same formula in different form. Means whenever h and x, means hk and xy, means new origin is given and new coordinates of point are given, at that time we can find old coordinates using this formula. If you write the same formula in this form, capital X is equal to small x minus h, capital Y is equal to small y minus k, then whenever new origin and old coordinates of point are given, we can find new coordinates of that point. In third way, h is equal to x minus capital X and k is equal to y minus capital Y. This is the different form of these two formulas, where when new old coordinates and new coordinates are given, at that time we can find the new origin or origin where, or the point where the origin is shifted. So these are the same formulas but in different forms, and in these, due to these different forms, we can see the different examples based on these three forms. Let us see examples on this. Let us see example number 1 on first formula. If the origin is shifted to the point if origin is shifted to the point 2, 3, the axis remaining parallel, here the axis remaining parallel to the original axis then find the new coordinates of the point First A, that is 1 3. First point A is 1 3, and second point B is 2 5. Here what is given? Given the new origin, that is 2 3. New origin is nothing but HK. So here new origin is 2 3. Therefore H equal to 2 and K is equal to 3. It is given. Also, we have to find the new coordinates of point. Means obviously these are old coordinates. So these are old coordinates. The old coordinates of point A 1 3 are x is equal to 1 and y is equal to 3, and we have to find the new coordinates. Therefore the new coordinates will be capital X, capital Y, as capital X is equal to, what is given capital X? Capital X is nothing but small x minus h, and capital Y is equal to small y minus k. Let us put the values of small xy and hk in these two equations. We get here small x is 1, small h is 2, so we get it is equal to minus 1, and y, capital Y is equal to small y is 3 and k is 3, so it is equal to 0. So here x is equal to minus 1 and y is equal to 0 are the new coordinates of point A. Understood? It's very simple. What to do? Once again, here old origin is given, that's why h equal to 2, k is equal to 3. Old coordinates of point are given, that is 1 3, so small x equal to 1, small y equal to 3. And we have to find the new coordinates. New coordinates are nothing but, we call them as capital XY. So capital X is equal to small x minus h, capital Y is equal to y minus k. Put the values of xh and yk in these two equations. We get x equal to minus 1 and y equal to 0. So these are the minus 1 and 0 are new coordinates of point A. So point A is minus 1, 0 in new x dash y dash system, and this A13 is the same point A in old xy system. In similar way we can solve second one. Here values of small xy are 2 5, so we take here values of xy are 2 5. Point B will be 2 5, so x equal to 2, y equal to 5. Putting those two values here, we get 0 and 2. So this point B will be 0 and 2. Okay, this is the way to solve this first type of question. In this question, we have found new coordinates, means we have used this second method. Let us see one more example. If the origin is shifted to, example number 2. If origin is shifted to point O dash, whose coordinates are suppose 1 3, the axis remaining parallel to the original axis, then find the old coordinates. Let us see the change of word only. Old coordinates of point A and point B. We will rewrite the answer. Here point A is 5, 4 and B is suppose 3, 3. Then the same origin is shifted at 1, 3. Here we write new origin, or origin is shifted at O dash, or new origin HK is 1, 3. Therefore H equal to 1, K equal to 3. Then old coordinates we have to find. It means these are new coordinates. So here new coordinates of point A are 5, 4. Therefore new coordinates are nothing but capital X. So capital X equal to 5 and capital Y equal to 4. As we know that if small xy are the coordinates of old coordinates of point A, then we have formulae for shift of origin as small x is equal to capital X plus H or H plus capital X. Small y is equal to capital Y plus K. Just put the values here. X equal to capital X is 5 plus H is equal to 1. So we get small x equal to 6. And here capital Y is 4 and K is equal to 3. So 4 plus 3, that is equal to 7. So small y is equal to 7. So x equal to 6 and y equal to 7 are the old coordinates of point A, 5, 4. Similarly, we can solve for the point B, 3, 3. You will get here only two numbers different. Those are 3, 3. So 3 plus 1, that is 4, and 3 plus 3, 6. So we get here new point B as 4 and 6. Due to this new origin, we will add this origin here. 3 plus 1, 4, and 3 plus 3, 6. This is the second type of example. Let us see third type of example. In this third type of example, if old coordinates and new coordinates are given and if the new origin is asked, then let us see how to find that. In this example, if the coordinates if the coordinates 5, 14 change to coordinates of a point, these coordinates are 5, 14, change to 8, 3 by shift of origin, find the coordinates of the point where origin is shifted. if the coordinates of this point change to 8, 3, then this is old point, this is new point, or these are old coordinates of point, these are new coordinates of same point. Then by shift of origin, we find the point where origin is shifted, means what to find? New origin. Obviously this is new origin that we have to find. Let us start in the similar way. Here we start with the coordinates of old point and new points. The coordinates of old coordinates of a point old coordinates of a point are given as 5, 14. It implies x equal to 5 and y equal to 14. There. And the new coordinates of the point are given 8, 3, which implies capital X is equal to 8 and capital Y is equal to 3. Let the origin be shifted, origin 0, 0 be shifted at point O dash H T. Since we know that, or by formula for shift of origin, we can write H equal to small x minus capital X and K is equal to small y minus capital Y. So let us put the values of old and new points. X is 5, capital X is 8, here small y is 14, capital Y is 3, so we get H equal to 5 minus 8, that is minus 3, and K is equal to 14 minus 3, that is 11. So the new origin will be, therefore the new origin will be minus 3 and 11. So this is the way to solve third type of example in which new origin is asked. So these are the three examples based on the same formula. Let us see fourth one, which is the application of this formula. These are three examples which are based on this formula directly. Now we will see the application of shift of origin. How this shift of origin is useful in solving the examples of locus, straight line, circle, ellipse, parabola, hyperbola, all those conics. So this shift of origin is very much useful and important in further all topics of geometry. Let us see one. Example number 4. Obtain the new equation of the locus. Here the equation of locus will be given. For example, let us take here one example as locus as 3x minus 1 plus 2 equal to 0. We have to obtain the new equation of the locus if the origin is shifted to the point 2, 2, so that the axis, so that the new axis remain parallel to original axis Let us see the solution of this question. Once again, what is given here? Here the origin is shifted to the point. This is the new origin. Obviously it is HK. The origin is shifted at point 22, that is HK. Therefore, H equal to 2 and K is also equal to 2. Here, let old coordinates be xy and new coordinates be capital X, capital Y. Then we have small x is equal to capital X minus h, capital X plus h, and small y is equal to capital Y plus t. Always remember, this small x is old, that's why it's big. This capital X is new, that's why it's small. So always add something in small number so that we get big or old number. In the same way for y. Here, therefore, now put these values of x and y in this given locus. This is the equation of old equation of locus, and we have to find the new equation of locus. Therefore, the given locus 3x minus 1 plus equal to 0 becomes 3 into small x is capital X plus h minus small y is capital Y plus k plus 2 equal to 0. Put the values of h and k as 2, we get 3 into x plus 2 minus y plus 2 and plus 2 equal to 0. So we get this as 3x, then minus y, this is 3 into 2, that is 6, this minus 2 plus 2 get cancelled, remains only plus 6, that is equal to 0. So this is the new equation of line. We take another locus here. The equation of locus is x square plus y square minus 3x equal to 7. Here the new origin is same, that is 2, 2. So the origin is shifted at point 2, 2, that is hk. Here let old coordinates be xy and new coordinates will be capital XY. Then we have the same formulae. As the origin is 2, 2, we get the same small x and small y. The given locus is x square plus y square minus 3x equal to 7 means minus 7 equal to 0. Let us put the values of small x and small y. This, so we get capital X plus 2 bracket square plus capital Y plus 2 bracket square minus 3 times capital X plus 2 minus 7 equal to 0. If we simplify this, we get x square plus 4x plus 4 similarly y square plus 4y plus 4. Next one is minus 3x and minus 6. And last constant is minus 7. If you observe here, then x square is single term, y square is single term. So write it as it is x square plus y square. Now 4x minus 3x is only single x. Y 4y as it is. Then constants 4 minus 6 and minus 7. This is minus 2 minus, that is minus 4 plus 4 8. 8 minus 7 minus 1 minus plus 1 minus 6, that is minus 5 equal to 0. So we get this as the equation of same locus in other form. Here the origin for this locus is 0 0, but the origin for this equation is 2 2. So this is the new equation of locus. Let us see one more here of the same type. The equation is xy minus 2x minus 2y plus 4 equal to 0. If this equation is given, then we have to find the new equation of locus, same locus. If the origin is shifted to the point same 2 2. Obviously, let us take the given equation of locus, that is xy minus 2x minus 2y plus 4 equal to 0. There is no change in this matter. Put the values of small x and small y from these two equations in given equation of locus. We get x plus 2 into y plus 2 minus 2 times x plus 2 minus 2 times y plus 2 plus 4 equal to 0. If we open these brackets, then in this multiplication we get xy plus 2x plus 2y plus 4 minus 2x minus 4 minus 2y minus 4, and this last plus 4 equal to 0. If you observe here, then this plus 4 minus 4 minus 4 and plus 4 constants get cancelled. Remains xy, this plus 2x and this minus 2x, they get cancelled with each other. This plus 2y and this minus 2y, they also get cancelled with each other because both terms are in opposite signs. So remains only xy equal to 0. So this is the new equation of locus, or this is the required equation. This is the required equation of locus in new system. If you carefully observe this equation, then let us see that this xy equal to 0, it can be obtained if we consider here x equal to 0 and y equal to 0. X equal to 0 is the equation of y axis, y equal to 0 is the equation of new x axis. And if you take the product of these two equations, we get this xy equal to 0. Product of left hand sides and product of right hand sides. So this xy equal to 0 is nothing but the combined equation of these two axes, x equal to 0 and y equal to 0, which are in new system. But if you think about old system, then what is this? This is also the combined equation of, here two axes are there. Axes are nothing but lines. So this is also the equation of two lines in old system. Let us see the figure of this. If you consider that origin is shifted at 2, 2. Here is point 2, 2. Here is O. This is O dash 2. At this origin O dash, x equal to 0 is new x axis. This is capital X equal to capital Y equal to 0. And at this point, this is capital Y equal to 0. This is our axis, but its equation is small y equal to 0, and the equation of y axis is small x equal to 0. So what will be the equation of, now these are the equations of axis. This is our actual x axis, its equation is capital Y equal to 0. This is our actual capital Y axis, its equation is x equal to 0. This y equal to 0 and x equal to 0 are these two equations, and this is their combined equation. If we find the equations of these new axes in old system, then the equation of this axis or this line, it will be actually y equal to 2. Small capital Y equal to 0 is nothing but small y equal to 2, and capital X equal to 0 is nothing but the small x equal to 2. So if you take the multiplication of these two lines, if you take the multiplication of these two lines, x equal to 2 and y equal to 2, x equal to 2 is one line, this is another line, that is y equal to 2. If you write these equations in this form, x minus 2 equal to 0 and y minus 2 equal to 0, and if you take the product of these two, then it will be x minus 2 into y minus 2 equal to 0, and after simplification we get xy minus 2x minus 2y plus 4 equal to 0. That is nothing but the given locus in old system. So this is the equation of these two lines in old system, and xy, capital Xy equal to 0 is the combined equation of the same two lines which are the axis of new system. So here locus is not changed. This equation represents these two lines, this equation also represents the same two lines. So locus are not changed, their forms are different, because this is the equation of locus in original system and this is the equation of the same locus in new system. So remember that we are not changing the locus, we are changing its form only, and that is the main use or main characteristic of this shift of origin. So I think we have solved so many examples based on this shift of origin. If you learn all these examples carefully once again, and if you try to solve the similar examples, then I think you will become fluent in using the shift of origin in geometry.